Welcome! In this video, we will learn how to find molar mass. Now, finding molar mass is a very important topic in chemistry, so you're going to want to feel very comfortable finding it. Now, what is molar mass? It's going to be the mass contained in 1 mole of whatever compound you're talking about, and usually molar mass is going to be counted in the unit of grams. It's essentially the total weight of the compound. For example, if a compound has 2 oxygen atoms, then the molar mass of that compound is going to be the weight of 2 oxygen atoms, and that weight is going to come from the periodic table using the atomic masses. Now, a few notes on finding molar mass. First, you're going to want to make sure that you have the chemical formula. So if you have a chemical name, you're going to want to convert that to a chemical formula. Next, you're always going to want to have your periodic table very handy when you're finding molar mass, because you're going to need to find the atomic masses for the elements in that compound. And the last note here is that when you find molar mass, pay attention to the number of atoms of that element in that compound. So is it 1 atom, 2 atoms, 3 atoms, and so on. What is the molar mass of sodium carbonate? In this example, we have the chemical name, and we know that from our notes, we need to have the chemical formula. So first of all, let's break this down. Sodium has the symbol Na, and its charge is +1, based on its position in the first group of the periodic table. And carbonate is a common ion, also called a polyatomic ion, and this is going to have a formula of CO3 -2. Now, when we put these two parts together, sodium carbonate needs to be neutral, so its charge needs to be 0. That means that we need 2 sodiums and 1 carbonate ion. And that way we have a +2 coming from 2 sodiums and a -2 coming from the 1 carbonate. Now that we have the chemical formula, let's move on to the next step. This is the step in which you will use the periodic table to find the atomic masses of each element. Let us start with one element at a time. Let's do sodium first. For sodium, we have an atomic mass of 22.99, and we're going to multiply this number by 2, because there are 2 sodium atoms, given by this little number here. So we have our first element done. Next, we're going to add in the weight of 1 carbon atom. So looking at the periodic table, we see that carbon has an atomic mass of 12.01, and there is just 1 carbon, so we can just multiply this number by 1, okay? And then we're going to add our mass of 3 oxygens. Oxygen has an atomic mass of 16. We will multiply 16 times 3, because there are 3 oxygens. When you do 22.99 times 2 plus 12.01 times 1 plus 16 times 3, you're going to get 105.99 grams per mole. The notation here, grams per mole, is simply based upon the definition of molar mass, meaning that in 1 mole of sodium carbonate, there are going to be 105.99 grams of sodium carbonate. Alright, and so in the end, 105.99 grams per mole is going to be our molar mass. Now, what would you say is the molar mass of HCl? Also called hydrochloric acid? We start off with the chemical formula. We have 1 hydrogen and 1 chlorine. And now we're asked to find molar mass, which means we need to add the weight of a hydrogen and a chlorine. Again, looking at the periodic table, we see that hydrogen has an atomic mass of 1.01. There is 1 hydrogen atom, and so we will multiply this by 1. Next, we're going to add in the weight of a chlorine. So a chlorine is going to have an atomic mass of 35.45. And there is going to be 1 of those chlorine atoms. 1.01 times 1 plus 35.45 times 1 is going to give you 36.46 grams per mole. Just if you're wondering, the atomic masses are in grams, so we can designate that unit if you're interested. Now, a tip here for working faster through molar mass problems is that when you notice that there is just 1 atom of an element, such as hydrogen, you don't have to multiply by 1. Okay, so this part is unnecessary. That's because 1.01 times 1 is exactly the same as just 1.01 alone, because anything times 1 is just itself. Okay, so we could just cancel out this one too for chlorine, because there's just 1 of them. So in the end, we can simplify this to adding 1.01 plus 35.45. Find the molar mass of glucose, and here we have the formula. Glucose has 6 carbons, 12 hydrogens, and 6 oxygens. And so that is what we are going to account for when we find the molar mass. Now let's deal with the 6 carbons first. Carbon has an atomic mass of 12.01, and there are 6 carbons, so we need to multiply this atomic mass by 6. Next, we're going to add the mass of 12 hydrogens. Now, hydrogen, as we said, has 1.01 for its atomic mass, and we will multiply this by 12 because there are 12 hydrogens. Finally, we will add the weight of 6 oxygens. Oxygen has an atomic mass of 16, and we will multiply this by 6 because there are 6 oxygens. Now see if you can find the molar mass of KBr, also called potassium bromide. In this example, we have a potassium atom, and we also have a bromine atom. And so when we find our molar mass, we need to add up the weight of one potassium and the weight of one bromine atom. Potassium has an atomic mass of 39.1 grams. And because there is just one potassium, I'm not going to bother multiplying by 1, as that will just give me the same number. And to this, I will add the weight of one bromine atom. Bromine's atomic mass is going to be 79.9 grams. Adding these two numbers will give 119 grams per mole. Now that is the end of this video. There is a link down below for science and math tutoring, my website, my publications, and my supplies. If you're looking for more videos to watch, I have one here which is my latest video, and one here which converts molecules to moles. Thank you so much for watching, and I will see you next time.